Now this is what in continuation with my previous lecture, the problem, I think this problem is actually over, but I am going to tell you here this star values, as I earlier said also in that lecture. We can either write this value, consider this value as +1 or -1. So in this example actually I have considered this value as +1. Now I am also going to consider this value as -1 and I will get the same value. How? So I have written this here. Have a look. So this is what my input is. This is what my input is, 0 0 1 1 0 1 0 0 1. Now what I have considered here, this value ak -1. Okay, ak -1. Now first of all I can write the polarity of this. 0 means -1, 0 -1, 1 + 1, 1 + 1, 0 -1, 1 means +1, 0 -1, 0 -1, 1 + 1, because we are passing it through the level shifter, and 0 means -1, 1 means +1. Now this -1, since this is what the delayed version of this, so this -1 will be going here, this -1 is going here, this will be here, this will be here, likewise this will be delayed. So this will be the delayed version of this AK. Now the next value we are going to find out is CK, that is what the output of the Duobinary encoder, CK, which is AK plus AK -1. So we'll have to make the addition of this 2, -1 -1 -2, -1 -1 -2, +1 -1 0, likewise 1 + 1 2, -1 + 1 0. We are getting this values. The next is to write these two values, AK cap -1 and AK cap. So first of all we cannot write this value. First of all we can write this value, AK cap. So what is the value of AK cap? CK minus AK -1 cap. So whatever the value that we have considered -1, now same value we'll have to consider here also at the receiver side. So -1. So now this is what the delayed version. So this -1 will be going here, -1, and now AK cap is CK minus AK cap -1. This minus this, CK minus AK cap. So -2 minus -1 means -2 plus 1. So -2 plus 1 is -1. Now this -1 will be going here. So -2 minus plus 1 is -1. Now this -1 is going here. 0 minus is +1. This one is going here. 2 minus 1 is 1. This one is going here. 0 minus 1 is -1. Likewise we are getting this value. Now the final value is BK. So you know the decision, this is what the output of the decision device. If this AK value, AK cap value is less than 0, it will be 0, and greater than 0 it will be 1. So minus means less than 0, so it will be 0, and greater than 0 means plus value. So 1 1 will get, since greater than 0, so 1, greater than 0, so 1, less than 0, -1, so 0. So if you see this output and input is 1 and the same thing. So even though we are using -1 or +1, we are getting the same value. And the same thing we can see here, the error which we have introduced in the second bit. You can see the value of CK I can write first of all as it is, -2 -2 0 2 0 0, the CK value. Now this will be changed as that of the previous. So this value I have written as it is. Now the error is introduced in the second bit. So -2 I can write it as 0. It will be reduces to the 0. So -2 0. Then rest of the values as it is. Now I can then write the value of AK cap -1 and AK cap. So first of all I can consider same value which I have considered here also, that is -1. This -1 will be shifted here, and this is the same operation. This minus this we will get here, this will be shifted here, and likewise we are getting this, and finally the output of the decision device, that is BK cap. We know less than 0 value, that is negative value means 0, and positive value means 1. So negative value 0, positive value is 1. Negative value 0, positive value is 1. This is how we are. So if you see, this is what the output sequence. Now if you see since the error is generated in the second bit, so actually we wanted to receive 0 in the second bit, but we have received 1. Now the third bit we wanted 1, but we have received 0. Fourth bit we wanted 1. Okay, this bit is properly received. 0 0, this is also properly received. 1 1 properly received. 0 0 also properly received, but these two bits are not properly received. They have received with the error. It means what? Once the error is introduced in the transmitted sequence, that is CK, this is transmitted sequence, then it will also produces the error in the rest of the received sequence, which will causes the problem. This is what the drawback of the Duobinary encoder without precoder. Now to avoid this, we are going to use Duobinary encoder with precoder. Now let us have a discussion on that. So I am going to here now discuss Duobinary encoder with precoder. So for what purpose we are using Duobinary encoder with precoder? In order for avoiding the error in the received sequence. So in order to avoid the error propagation, precoder is used. So this is what the precoder, which is also called as differential encoder, we are going to use before this Duobinary encoder. Now this we are going to use here XOR gate. To this XOR gate, two inputs are there. First input is decay, that is the input sequence 0 or 1, and the another sequence is decay -1. It's a delayed version of decay. So this decay will be given to the level shifter, which will convert this into the two level sequence, means 0 is converted into -1, 1 is converted into +1. This AK will be going to the summer or the adder, and along with the second input is the delayed version of it, that is AK -1, and at the output CK we will get the addition of this 2. So let's see what we'll get. The binary sequence which we have applied here, BK, is either 0 or 1. It is either 0 or 1. Now output of the precoder means decay. So decay is equal to what? This BK XOR with decay -1, which we have written here, BK XOR with decay -1. Now this decay is passing through the level shifter, we will get AK. So when decay is 0, after passing it to the level shifter, AK is -1. So if it is 0, we will get -1. If it is 1, we will get +1. This is what the value of AK. Now this AK we will give it to the adder, and that output of adder is nothing but the output of encoder, Duobinary encoder. So that is what the value of CK is. And what is CK? It is AK plus AK -1. I have written here. CK is AK plus AK -1. Now the value of CK is either 0 or plus or -2. So we will get either 0 value or +2 or -2. That will be, so uncorrelated sequence 0s and 1 will be converted into 3 correlated sequence with levels 0, +2 or -2. When will we get 0? If the value of BK is 1. And when will we get this plus -2? When the value of BK is 0. We'll see after going through the numerical how for BK is equal to 1 we are getting CK 0, and for BK is equal to 0 we are getting plus or -2 value. Now let us moving on to the receiver side. So this is what the receiver, whatever the value of CK that is transmitted by the encoder, it is coming to the rectifier first, which will be making mod of this transmitted sequence, or I can say here it is the received sequence. So we are getting mod of CK, and then it is given to the decision device, which will set the threshold level at 1 now here, and it makes certain decision. Now what is the decision? So this is basically an algorithm we can write. What kind of decision it is? So the output value we are getting BK is equal to 1 if this mod of CK is less than 1. So whenever we are getting mod of CK less than 1, the value of BK we can get it as 1, and if the mod of CK is greater than 1, we can get the value of BK as 0. So please remember this decision. What kind of decision we are making here? If mod of CK less than 1, then it is the output is 1, and if mod of CK greater than 1, the output is 0. So let us start.